couple of days we learned about the tan-trig ratio, and we said that tan of an angle means the ratio between the opposite to the adjacent of that angle, and this only in a right triangle. Also, today we are going to learn two other trig ratios, also in a right triangle. So in a right triangle, we have two more trig ratios. One of them is called sine, and the other is called cosine theta. Sine is the ratio between the opposite to the angle to the hypotenuse, and cosine is adjacent over the hypotenuse. This is in a right triangle. So for this angle theta, this is the opposite across from the angle, and this is the adjacent. It is next to the angle and not the hypotenuse, and the hypotenuse is the longest side that's opposite to the 90-degree angle here. So sine is the ratio of the opposite to the hypotenuse, cosine is the ratio of the adjacent to the hypotenuse, and this is in the right triangle. Okay, so I will give you some examples. So the first example, if I have a triangle, this angle is 90 degree and we call this angle theta, and the length is 24, this is 26, and this is 10. So I can say that sine theta equal 26 over, no, I did a mistake, sorry. The hypotenuse has to be the longest side. So this is 10 and this is 26. So sine theta, the ratio, the trig ratio is the opposite over the hypotenuse, and cosine theta will equal the adjacent over the hypotenuse, and we can simplify this to make it 5 over 13, and we can simplify this and make it 12 over 13. And if we want to find tan theta, it will be the opposite over the adjacent, which is 10 over 24, which is 5 over 12. So this is how we find the three trig ratios. Okay, let's do another example. If we have a triangle that looks like this, and this is angle theta, this is a 90 degree, let's make this angle theta, and this is 7.6, this is 4.1, this is 6.4. So I can say that sine theta is opposite to theta, which is 6.4, over the hypotenuse that's opposite to the 90 degree, 7.6, and we can divide by 2, so 3.2 over 3.8. Cosine theta will be the adjacent to angle theta, so next but not the hypotenuse, which is 4.1 over 7.6, and if we want to find tan theta, it will be the opposite to angle theta, already programmed in the calculator that the ratio between the opposite to the hypotenuse in any right triangle that contains 26 will be the following. So let's try to find sine 26. This will be 0.4384. Okay, so the sine, I don't know, you can see it. The sine is this, this over here, sine, cosine, and tan. Okay, and if we want to find cosine 26, we press on cosine. We must calculate it in degree mode. We must have degree mode, otherwise everything will be wrong. So cosine 26 equals 0.8988. That means if I have a right triangle, and this is angle theta, and this is the angle 26, no matter how big or small this triangle will be, the ratio between the opposite to the hypotenuse will equal this, and the ratio of the adjacent to the hypotenuse will be this. No matter how big or small, as long as the angle is 26 and it's right triangle. Okay. So for example, if I said that sine 30 degrees equal 0.5 or 1/2, that means if we have a triangle like this and this angle is 30, the ratio between the opposite to the hypotenuse will be 1 to 2, no matter how big or small the triangle is, because if this is 100, this will be 200, and the ratio will stay 1, so sine 30 will equal 100 over 200, and that's 1/2, no matter how big or small the triangle is. Okay? So now if we want to find the angle, so let's say I give you that cosine theta, I don't know what is it, equals 0.7324, and I need to find the measurement of angle theta. So I would say the measurement of angle theta will equal cosine minus 1, 0.7324, and I use inverse, then cosine, then I will write the ratio that I have here, the number, the decimal, 0.7324, and I hit enter, and that will give me the measurement of the angle, 42.9 degrees. Okay, so in order to find the measurement of the angle, we use cosine minus 1. Okay, now if we have a triangle like this, and this is angle theta, and this is 400, and this is 500, and I need to find the measurement of angle theta. When I have a question like this, I look, this is the angle and this is the right triangle, so I can use sine, cosine, or tan. I want to determine which ratio I can use, sine or cosine or tan. When I look here, I found that for this angle, I know the one that's next to it and not the hypotenuse, and I know the hypotenuse. So which ratio that has both the adjacent and the hypotenuse, that ratio is cosine. So I have to use cosine because the information given me, forcing me to use cosine. So I would say cosine theta equal the adjacent, which is 400 over 500. Now cosine theta equal 4 over 5, which is 0.8. So that means measurement of angle theta will equal cosine minus 1, 0.8, and I can use the calculator and find that. So inverse cosine 0.8, and I will get that the measurement of the angle is 36.87 degrees. Okay. Now another example. If I have a triangle like this, this is a 90 degree, and this is angle theta, and this is 5 over, and this is 20. Okay? When I look here, which ratio I need to use to get theta? I look, this is theta, this is a right triangle, so I can use sine, cosine, or tan, depending on what's given. What's given to me is the one that's across and the hypotenuse. So opposite and hypotenuse. Which one of the ratios is opposite and the hypotenuse? It is sine. So sine theta equal 5 over 20, which is 0.25. So theta, measurement of angle theta will equal sine minus 1, 0.25. Then I go to the calculator and write inverse sine and put 0.25 and close and hit enter, and you will get 14.478 degrees. So that's what I want you to learn today, and I want you to do page 372 from number 1 to number 9, and tomorrow we'll continue with sine and cosine to find the missing sides. Okay, I am very happy with your performance. Please finish the work and send me questions if you have any. Have a wonderful day.